Hello friends, warm greetings and welcome to my YouTube channel. First of all, thank you for taking your valuable time and your interest in this topic. In this video, I'm going to talk about one of the most widely used heavy metal estimation index method called Geo-Accumulation Index, which is abbreviated as Igeo. This particular index method is basically used for determining the degree or the level of contamination of any specific heavy metals of interest in the environment. For your convenient information, this video constitutes of the following content. First, we will talk about the general meaning or concept of heavy metals in the environment. Then we will quickly see the name of the different indices used by researchers for assessing the level of heavy metals, after which we will dive deeper in detail into the Geo-Accumulation Index and its classifications, its formula, and also what do we mean when we use the term background value or background concentration or BN value in these index methods. And lastly, I will demonstrate the hands-on calculation of Geo-Accumulation Index using Microsoft Excel using some hypothetical data. To begin with, first of all, let us briefly try to understand what are heavy metals in the environment. Heavy metals are the naturally occurring elements found in the earth crust. Due to this, heavy metals are found to distribute in different living tissues of an organism and also in various components of the environment. However, under natural condition, the concentration or level is estimated to be very low or insignificant, with values ranging in part per million or in part per billion. Therefore, at such a low level or concentration, the heavy metals have no significant health impact or pose no potential health risk to any living organisms or the environment. Few examples of heavy metals are arsenic, aluminum, chromium, copper, cadmium, mercury, nickel, lead, and zinc. On the contrary, with modernization, industrialization, and advancement of human civilization over the past decades, various anthropogenic activities such as mining and presence of electrical and electronic industries, electroplating industries, pesticides industries, fertilizers industries, plastic industries, pulp and paper, pharmaceutical industries, industrial emissions, vehicular emissions, to name a few. These activities are known to release quantum amount of various pollutants, including heavy metals, into the different component of the terrestrial as well as aquatic environment, thus resulting into the exponential rise of heavy metals level in the environment. Now, when in the environment, these heavy metals later find their ways into the living organism through soil, drinking water, food, fish, air, etc. And through the process of bioaccumulation and biomagnification, these heavy metals are found to produce an adverse effect on plant, animals, and even on human health. So with this basic explanation, we can conclude that it is vital to monitor and assess the level and the degree of heavy metals in the environment. Generally, concentration of heavy metals is estimated or studied in sample of air, soil, water, plants, animals, sediments, etc. And for studying these, the analytical methods and estimation techniques adopted are totally distinct and different from one another. For example, soil analytical method and estimation techniques is totally different from that of the sediments analytical method and estimation technique. However, after analysis, for easy understanding, the analytical data or results obtained are subjected to different heavy metals indices of choices. Until date, there are varying types of index methods used for determining the degree or the level of heavy metals in the environment. And the most commonly used index method used are in this slide. However, as I mentioned earlier, in this video, I will be talking about Geo-Accumulation Index. Therefore, to catch hold of the other index method, kindly subscribe to this channel and click on the bell icon for notification of the new videos in the near future. Now, the greatest benefit derived from using any of the mentioned index method is it assists the researcher in clearly understanding the specific degree of contamination or pollution level of any particular heavy metals of interest that is studied. With that said, now let us dive deeper into Geo-Accumulation Index. First of all, Geo-Accumulation Index was developed by G. Mueller in the year 1969. Initially, the main focus of this index method developed by Mueller was to determine the heavy metals concentration in sediment samples. However, later different researchers employed this method for determining the contamination level of heavy metals in different components of the environment, such as soil, sediments, water, etc. The Geo-Accumulation Index is used as a tool to summarize and interpret any heavy metals raw analytical data into a single Igeo index value, which then specify and represents the contamination level of any specific heavy metals of interest. About Geo-Accumulation Index, it focuses on determining the level of only single heavy metals at a time. For example, the pollution level of arsenic in sediment X, pollution level of lead in sediment Y. This index method is classified into 7 different grades or classes, with index classes ranging from 0 to 6. And as you've seen in this table here, these are the 7 different classes of Geo-Accumulation Index with values ranging from 0 to 6. And these represents the Igeo value, whatever the calculation that you be carried out and whatever values that you get will be fallen under this category. So if the value is less than 0, it will represent that the sample is uncontaminated. Okay, and if the Igeo value obtained after calculation is between 0 and 1, it will indicate that the sample is uncontaminated to moderately contaminated. Similarly, if it is between 1 to 2, it will be moderately contaminated. If it's between 2 to 3, it will be moderately to heavily or strongly contaminated. And if it's between 3 to 4, it will be heavily contaminated. And if it's between 4 and 5, it will be heavily to extremely contaminated. And if the value, Igeo value is greater than 5, 5.1 and above, then that sample is said to be extremely contaminated. After calculation of Geo-Accumulation Index, we'll find that if the Igeo value of heavy metals is negative, then it indicates that there is no anthropogenic activities. Whereas if the Igeo index value is positive, it signifies the presence of anthropogenic contributions, and the level of contamination will keep on escalating with increases in Igeo value. Next, Geo-Accumulation Index is calculated using this equation. Igeo is equal to log to the base of 2 Cn divided by 1.5 into Bn, where Cn is the mean concentration of the ith heavy metals in the X samples analyzed. And 1.5 is the factor used as a constant because there is a possible variation of the background data due to the lithological variations. And Bn is the geochemical background value of the ith heavy metals in the X samples analyzed. You will be more clear about this when I do the calculation part in the later stage. Now from these equations, before we proceed into the calculation part, first we have to be clear about what do we mean when we say background value of the heavy metals. or what is the BN value here. So BN value or the background value is the natural compositional and mineralogical concentration of any specific heavy metals in an undisturbed or barren source. Or in a simple way to put it, it is the original natural concentration of any specific heavy metals in an undisturbed sources where there is no human interventions. Technically, the background concentration is also referred to as the reference or the control value. So the background value as per Mueller 1969 is the concentration of the heavy metals in the sediments during pre-industrial and period. For example, the heavy metal concentrations such as arsenic, lead, zinc, and copper is given here. These are just assumptive concentration that I get. Now, if the study is being carried out, let's say after the pre-industrial period, let's say 50 years later, in the same particular area, sediments of that particular area, whatever concentration of heavy metals that is obtained is compared with the data from the pre-industrial environment. This is how, according to Mueller, is the background value. However, in most cases, practically, it is not possible to avail and obtain the background value of any particular heavy metals of interest from the pre-industrial period. For example, some area which has there's no pre-industrial data as such. So it's difficult, right, to obtain the background value for such kind of area. So due to this reason, different researchers have adopted different approaches for acquiring the background value of any heavy metals of interest in order to perform their geo-accumulation calculations based on the related review of literature. So these are the different approaches adopted by different researchers for obtaining the background value. The first approach is it is obtained by using the heavy metal concentration from undisturbed source. Like I said, the reference value or the control value as a background concentration. And some researchers have used or have taken the geometric means of the observed value and or the metals concentration value. And some have also used the standard permissible limit, which is being prescribed by different agencies such as EPA, WHO, FAO, and BSI, etc. And also some researchers obtain the background value by using the predetermined values which has been given or produced or generated by other researchers. Some of the common one and famous one are these which are given here. However, in this video, I will be used, the background value is obtained by analyzing the undisturbed soil samples, and whatever values that we obtain from the undisturbed soil samples, that will be our background value or the background concentrations. Now, once we are clear with this, now we can move on to the calculation of the Geo-Accumulation Index. Let's open an Excel sheet. So for demonstration purposes, in order to calculate the Geo-Accumulation Index value, so first of all, we have to collect the soil samples, right? So after collecting the soil samples, then the soil samples are being analyzed. Let's say the heavy metals that are studied are iron, magnesium, zinc, copper, and lead. And then let us assume that the soil samples were collected from two different mining sites, mining site 1 and mining sites 2. And also to obtain the background value, the soil samples from the same area but from an undisturbed area, soil sample is being collected. And then these soil samples were from these three different soils, that is the undisturbed site, the mining site 1 and mining site 2. The soil sample collected were analyzed in the laboratory for these mentioned heavy metals. Now, after analysis, and let's say these are the hypothetical data that we obtain after analysis. So how do we perform the Geo-Accumulation Index calculation here? So once we get these hypothetical data like this, you'll get your data something like this. However, just a reminder, as I mentioned earlier, different researchers have used different approaches. So this value, it depends on how you how you want to generate the background value, or how you avail or how you obtain your background value. So this part might change if depends on you. Okay, but in my case, as I already mentioned earlier, again, samples from the undisturbed sites and whatever value that we obtain, that value will be your background value. Okay, that's now once you are done with this, once you have the data view, now you have to proceed to how to do the calculation part of the Geo-Accumulation Index. So Geo-Accumulation Index, Geo formula is Igeo is equal to log of the base of 2 by Cn divided by 1.5 into Bn. So what is the Cn here? Cn is the concentration, the mean value concentration of the particular heavy metals. Okay, so let's say the mining site 1. So what's the value of iron, manganese, zinc, copper, and lead? So go back to the previous slide. So just you have to do is just copy these values here and paste it here. Go to paste spatial values. So this is your Cn value. Similarly, let's see the Cn value for the mining site 2. So how much is it? Go to this slide, copy these values and paste it here. Paste value. Now see, Cn is the mean concentration value of the I parameters in the sample analyzed. Now, once you have obtained this, now we have fulfilled this part, right? The numerator portion. Now 1.5 is the constant value. Now we have see from the formula we have obtained Cn, and we have obtained we have filled the value of constant, and next is Bn. What is the Bn? Bn is the background value. So background value is the same, right? Background value is this, right? Undisturbed side. So you copy the background value from the undisturbed side and paste it here in your Bn value. Similarly, the background value for the mining site 2 is also the same. Have a look at these mining site 1 and mining site 2. You see that Cn, we have the data, 1.5 we have, and the background concentration also is there. So next, we have to fill this part. 1.5 is the constant into the background concentration. So put equal sign 1.5, right? Go to this slide, into Bn. Bn is the background concentration. Done. So this is your value for the denominator. Similarly, equal constant into background value, enter, and then this is the value of the next. We'll have numerator divided by the denominator. So equal sign. What is your numerator? Cn. Cn value is here, right? Divided by what? The numerator. We have already come. This is the numerator part. So it's equal to this. So you have obtained this value as well. Similarly, for mining site 2 equal to, what is your numerator? Cn. Cn is this value for iron divided by C, denominator. Denominator is equal to this. So now you obtain this value. Okay, done, right? Now we have done this part, but we cannot ignore log to the base of 2. So in this case, you click equals to log. You see this log, right? Double click and log, then click on the value obtained by after dividing numerator by the numerator. So this, put a comma 2 due to the base of 2 and then close bracket. So your value is 2.01. Then from here, just drag it down, you'll get the other values. Similarly, equals to, type log, double click in the log here, then the value of the numerator divided by the numerator is this value, then put a comma and put 2 to the base 2 because of to the base 2, close the bracket, and this way. Now you get this value, and after this, then you drag it, right? So these are the Igeo value for mining site 1 for different heavy metals, and these are the Igeo value of different heavy metals for mining site 2. All right. Now to express the results of Geo-Accumulation Index for mining site 1 and mining site 2 for different heavy metals studied, let's copy the Igeo value. What is the Igeo value for mining site 1? The Igeo value for mining site 1 are these, right? Copy and paste spatial. So these are the Igeo value for mining site 1. What about, let's copy the Igeo value for the mining site 2. And then paste it here. All right. Now we have obtained the Igeo value. So the next is we have to find out the Igeo class and the Geo-Accumulation Index. We have to use the Geo-Accumulation Index classification given by Mueller, right? So this is the one, remember, that I showed you earlier. The Igeo value for mining site 1 for iron is 2.01. So 2.01 is somewhere here, right? It's plus 2 less than 2 and less than 3. So it's between this here. So the Igeo class for iron will be 3, right? So for manganese, it's 1.74. So 1.74 is this, right? It's between this and this. So it'll be class 2. 1.88 as well will be class 2. Then 4.94 will be in class 5, right? And minus 0.1 will be in class 0. See? So this is the Igeo class for mining site 1. Similarly, for mining site 2, 2.83 will be in class 3. 5.58, so it's greater than 5. This will belong in class 6. And then 1.34 will be in class 2. So now you have obtained the Igeo value and you have obtained the Igeo class. So with this, so this is how you will get your results. See, so from here, you'll be able to identify that from the different metals analyzed from mining site 1, the copper is heavily to extremely contaminated, all right, in mining site 1. And similarly, if you look at mining site 2, you'll find that even here as well, the copper is found to be extremely contaminated. So copper has the highest Geo-Accumulation Index here. Okay. So these are the references that I use while preparing for this video. So with this, we have come to an end of this video, and I hope through this video, you'll be able to understand what they mean by Geo-Accumulation Index, what are the different classifications, and what is the formula used in Geo-Accumulation Index, and most importantly, how to do the calculation for Geo-Accumulation Index. So with this, we have come to an end of this video. So thank you so much for your attention, and I hope you will gain more knowledge about this particular index method after watching this video. Great day ahead, and God bless.